All right, so let's do another one here. I've got it all written out so you can just watch and listen. I'll follow along. So inside here is x squared plus a squared. So that's using the tangent. So x equal 2 tangent theta. So again, don't right away find the derivative, dx. So carry along the 2. Derivative of tangent is secant squared theta d theta. Okay, so everything from x's all changing to thetas. It gets huge. So in the numerator, I just put the dx up on the top. So this is the dx, the 2 secant squared theta d theta. The x squared gets replaced with 2 tangent theta squared. So that gives me 4 tangent squared. And then under the radical, the square root of x squared. So I'd have 4 tangent squared theta plus 4. Remember, you're getting rid of the radical, so focusing on that. So I just pulled it off to the side. So this, I could factor the 4 out, and the root 4, I should say, and that gives me tangent squared theta plus 1, and that's the same as secant squared under the radical, so that gives me secant. So this this radical turns into 2 secant theta. This here turned into 2 secant theta. So now let's go simplifying. This one, I needed to change to sines and cosines. So let me just show a little bit of work here. So these 2's cancel, so I have a 1/4 on the outside. So here's my secant of theta that was left over. There's my tangent squared. And so this is not a tan secant combo. So I would have, lost my 1/4. I would have had to rewrite this as 1 over cosine, sine over cosine, carry the 1/4, multiply by the reciprocal. So I get, oh, I forgot to square these guys, right? This is squared. Multiplying by the reciprocal, I get cosine squared over sine squared times a 1 over cosine. So one of the cosines goes away, so I get a cosine to the 1 power sine squared. So I skipped all those steps, but once you got to here, there was no other choice except to change to sines and cosines, because this tan secant combo that we just did in the last section is not going to work if I have a denominator. So I get to here. Whew, now what? Well, I see in the denominator, if I let u equal sine, the du will equal cosine. So I get 1 over u squared. Then I take the antiderivative. I get to here. I'm in u's. I need to get back to thetas. So put the sine back in. Then we go back to the triangle. So where does the triangle come from again? The triangle comes from here. So I would have x over 2 is tangent of theta. And I need to get sine. So here's opposite over adjacent. This other side will give me x squared plus 4. So how do I get sine? It was sine in the denominator, so it's like saying cosecant, correct? So negative 1/4. Let me just write it again. Well, negative 1/4, the same as cosecant, which would be hypotenuse over opposite. And if I move the 4, multiply the 4 in, there it is. Shoo! Okay, moving on to a little more challenging. So what if it's 16 minus 9x squared? I need to have an x being squared. So the x being squared is 3x. So it's 3x that's being squared, and the a comes from this, 4 squared. That's where the number in front of the trig comes from. So I want to solve for x first, so I get 4/3. Now I'm going to find the derivative, so I get 4/3 cosine of theta d theta. Okay, so I'm going to substitute in. So instead of 3x, I'm going to put in 4 sine theta. So be really careful here. I would not suggest using this one, since I know exactly what 3x is equal to. Don't go fractions. Don't put in fractions if I don't have to. So 3x gets replaced with 4 sine theta. Then The dx, that one has a fraction. There we go. We can just leave it out there. I don't want fractions in my radical. Remember, I'm trying to get rid of the radical, so I want nice whole numbers where I know I can factor, the same number out. This will happen every time. If it doesn't, you made a mistake. So root 16 comes outside, and I have 1 minus sine squared of theta, which I know is cosine squared in the radical. So let me just go slow. So I'd have 4 from here and a 4/3. So 16/3 cosine squared under the radical and another cosine, right? So this square root of cosine squared gives me 1 cosine. There's another cosine, so there's my cosine squared. How do I do that? Oh yeah, the half angle formula. So this turns into 1/2, 1 plus cosine of 2 theta. Then I take the antiderivative, so carry the 8/3 along. Integral of 1 with respect to theta is theta. Then cosine of 2 theta, taking the antiderivative, I get 1/2 sine of 2 theta. Whew. Okay. When you get to here, you must use this identity because I need to get information off the triangle to get it back to x's, and I can't get information off the triangle with sine of 2 theta. So you must use this. So rewrite this as 2 sine cosine, and so now I get to this. So now I'm going to get the information off the triangle. Remember, this is the original substitution. So here's my triangle. So I'll have opposite over hypotenuse. So this will be 16 minus 9x squared. Okay, the theta, the only time that you're ever going to use the inverse trig function is when you have to solve for theta, like I have in this problem, this theta. That's the only time you use the inverse trig function. The other times, sine of theta, that's 3x over 4. Cosine of theta is adjacent over hypotenuse. So now it's all in x's and we're done.